Okay, 2012 AMC. This is problem 17 from the AMC12B. And it says square PQRS lies in the first quadrant. Points 30, 50, 70, and 13, 0 lie on the lines SP, RQ, PQ, and SR respectively. What is the sum of the coordinates of the center of the square PQRS? Okay, so this is a tricky little problem. It took me a few minutes to figure it out, but I did get it eventually. And so here's the idea. We have our points, okay? We have 3, 0. We have 5, 0. We have 7, 0. And then way out here, let's see, it's going to be maybe about here. That's pretty accurate. We have 13, 0. And what we end up having here is this. These points will determine, they're on the lines that are part of a square. And so I'm going to just connect some line segments so we can see what's going on. This is pretty decent, not great, but, and that's a square. What a lovely square. Okay, so this is the square. Let's see if I can label this correctly. I think P, Q, R, S. Okay, so what we're going to end up doing now is use some similar triangles to find the slopes of line PS and line SR. They're opposite reciprocals because this is a square, so that's a right angle. And then what we're going to do with that is we're going to use that and the midpoints on these intervals to create the lines that go through the center of our our square. And these points obviously are 4, 0 and 10, 0. And we know that has to be right in between these two lines. It's the midpoint of traversal. So, and by solving the system, find the intersection, we'll know what's the center of our square is. Okay, so let me redraw this a little bit bigger. And what we're going to end up with is this. We have this lovely right triangle. We have a square inside it. And what ends up needing to happen is I need to have the distance all the way across this distance D, I'll actually draw it in there, which can be found as one of the legs of a little right triangle here. I need this D to be equal to this distance here. Let me draw it here, which can be part of this right triangle out here. Okay, because I know this is 2, distance from 3, 0 to 5, 0, and I know this is 6, distance from 7, 0 to 13, 0. I know that the scale factor from here to here is 1 to 3, which means that this must be 1/3 of D in order for when I multiply by 3 to get this D over here. Or, in other words, this must be 3D out here. Okay? Using that and another similar triangle, there's probably a better way, but I just kept on tossing in similar triangles until we got it. This triangle right here has to be similar. Okay, well that's not a triangle, there we go. And if I have mark this as 1, this M will give me the slope, but in order for it to be similar to this right triangle, because the reason is we have a 90 degree, we have complementary angles, so this angle is congruent to this angle, and angle-angle similarity. The slope has to be 3 of this line, and the opposite reciprocal slope, negative 1/3 of this line. That means that my equations of the line through 4, 0 is going to be y equals 3x minus 4 plus 0. That's point slope form. The equation of the line going through 10, 0 is going to be y equals negative 1/3 x minus 10 plus 0. And I'm going to just do a little system, so I'm going to set these two equal to each other. So I have negative 1/3 x minus 10 is equal to 3x minus 4. I hate fractions when I can avoid them. They might make my life harder, so I'll multiply both sides by negative 3 to get x minus 10 is equal to negative 9 x minus 4. Distribute through, x minus 10 is equal to negative 9x plus 36. I'm going to add 9x, add 10, so I get 10x is equal to 46, which implies that x will equal 4.6. And I'm going to take that back to my first equation right here, substituting in 4.6 to see that y will equal 3 times 4.6 minus 4 is 0.6. 3 times 0.6 is 1.8. And so this point in the middle of the square here is, I'll mark it down here, 4.6, 1.8. And when I do 4.6 plus 1.8, that's what they're looking for, the sum of the coordinates, I will get 4 carry the 1, 6.4, and my answer is C.